My name is Nathaniel Manning. I'm going to talk to you a little bit about the BRCK and Ushahidi. I'm going to start off by telling you a little bit about myself. I started working with Ushahidi about 3.5 years ago. I'm going to tell you a little bit about what that means. When I met Juliana, who's here, who's our executive director, I was at a program here in the Bay Area that was all about how technology was going to change the world and help solve these big problems, how this breaking edge technology is going to fix all these things like poverty and climate change and water issues. And I was struck by the fact that a lot of these issues were taking place in the developing world. And one of the only people who was speaking who had started a company and was actually from the developing world was Juliana. Everybody else was very smart and very intelligent, but probably a PhD student at Stanford or running a company here in Silicon Valley. And I was really taken with her work. So I got involved. At the time, the company Ushahidi, what it does, it means testimony or witness in Swahili, and we create open source software that allows people to tell a story, give them voice. It was created during the elections in Kenya 7 years ago, where there was a lot of violence. But that's not the story I'm going to tell you today. Juliana and the work, and the folks who started up the organization had the chance to kind of create this tech company in Kenya that then expanded to be hiring, frankly, white American men in Silicon Valley. And I think that's pretty cool. And one of the reasons why that was she had, and the folks that she started the company with were part of the internet at an early age. They were 4 bloggers who wrote about technology in Africa, who wrote about this, and they had the chance to live in the States. And that's how they knew each other. And so this was really influential to us. So I'm going to tell you a little bit about how that story turned into what I'm talking about here. To give you a couple numbers, only about a quarter of the developing world is connected to the web. Interestingly enough, so of all the people, about 40% of the world is connected to the internet. And 60% of them are in the developing world. The majority of people online today are in the developing world, but 98% of the people in the developed world are already connected. That means that everyone who's going to get online in the future is going to be in a country where infrastructure is poor, where infrastructure is really different than the infrastructure that's existed for everyone else who's already connected. A couple other interesting facts that children 0 to 14 in Africa are going to be doubling over the next couple decades. And that, what we found is that internet access in schools really matters. It's access to information. It's this access to the world of knowledge, to the Library of Alexandria, right? That we've all been contributing to, particularly over the last 20 years that the web's been in existence. But we asked ourselves, why do we use the technology that we designed to be used in London and Los Angeles for the States? We've had 100 years of copper wire laid across this country. Why are we using the same routers and modems and tools in Nairobi and New Delhi? And that was really the question at hand. And it actually was just really us trying to solve our own problems. As I told you, we're a software company. About 70% of us are developers. We're based all over the world. About half the team's in Nairobi. The rest of us are elsewhere. And it's really frustrating when you need to write code or create something and the internet goes off. You can't do your job. And as I told you, the majority of the people online are in those countries. So it's just frustrating. So we set around to try and change that. We started developing a modem and router that was designed for infrastructure-poor places. And it's called the BRCK. And that's what it looks like right there. And I can show it to you. And I'll tell you a little bit about what it does and why it's that. We didn't take into assumption the design realities, the case study of the situation that all of the devices that had been built before it were assuming, which is pretty much ubiquitous electricity connection, more or less, wire, cable line laid, like I said, across the entire country. Pretty thorough mobile connectivity. These were assumptions that have been used for the dongles or the MiFi devices that you might use here, or tethering off your cell phone. It's a great solution. Try to do that in Kenya. It doesn't work very well. So we set out to try to think about what it has. Is it has a battery that can charge on anything from a solar panel to a car battery. It'll last for 24 hours. It creates a Wi-Fi hotspot. It allows you to connect to the web. Up to 20 people can connect to it. It can mesh network. It can connect via either the mobile satellite, mobile connectivity like your phone, right, through a SIM card that'll work in any, about 143 countries on the GSM network. And then also through an Ethernet port. And then it just intelligently switches between those. And then it's very extendable. It has these ports that allow you to plug in other things, and I'll get more to that later. So as I started off telling you this story, and I said, it's interesting, I'm based here and I work for this organization in Nairobi. The entire BRCK team is based in Kenya. And all that cool stuff I told you about the BRCK right now, it's got all this neat stuff. It actually has a hard drive in it too. Like I said, it's extendable. You can locally store content, which is going to come up again more later. But my favorite part of this entire thing is a line on the back that says, "Designed in Nairobi, Kenya, manufactured in the United States." And if you have looked at the back of anyone's Apple device, it says designed in Cupertino, made in China. That's one of the really neat parts. I think that's the neat story here. And so I'm going to tell you a little bit about what that's looked like. This entire thing was built. That was our first prototype. Pretty janky. We were bringing over. Every time I go to Nairobi, I bring over cases of Arduinos and electronics and things, and I hope I don't get stopped. Second one looked like this, like molted plastic and glue put together, just trying to do our best. The hard part is the tools to build these things, they don't exist in Kenya, right? You can't, it's really hard to get access to a 3D printer or a CNC machine. And this is the big issue, is that the problem there, your customers there, the folks that you're testing with are there, but everything's being built somewhere else. Everything's being prototyped. We have another friends that do work in the area, and their designers, they built something else. They built a toilet, in fact, would design it in Seattle, put it in his bag, fly it over every corner, test it out, fly it back, take it back to the tech shop, change it around a little bit, fly it back again next quarter. It's just extremely wasteful, but it's because there's no way to build there. And we got a little fancier. We bought a Pelican case and put some drills through it, and this was one of the first very well-working ones. Now it's starting to look like a brick. Now we got the idea of our designs. And then this, as we're getting closer and closer, this is starting to be our ideas. And then this was one of the first ones. We actually ran a Kickstarter about 1.5 years ago, and this was the one at the time, very first prototype that looked somewhat like what we wanted it to look like. So we jumped, and that went really well, actually. We raised about $170,000, and that kicked off and gave us the clarification that we did have market demand. And now it looks like that. And like I said, that was designed in Nairobi. A lot of people wouldn't believe that even a few years ago. And what we want to hope and believe is that probably the way that 50 years ago, or really even 30 years ago, no one would want to buy a Korean television, right? You wouldn't really think, at that time, maybe Japanese. You'd never think to buy a Korean car or television 30 years ago. Now, they're the largest television makers in the world. We really hope that that's people's perspective for us, that we can talk about East Africa, and that at least in 20 years, no one's going to balk about electronics device that was made in Nairobi on the back. That, I think, is the really inspiring and hopefully big idea. There's a few things that fall into this. So I said there's a lot of things designing that we're doing, building. there's something called Juakali, which means hot sun. It's about people making stuff. We've seen a lot of this. We run Maker Faire Africa. This is just some other cool ideas that have come out. As we've tried to build things, this is one guy creates, you put seeds in the top and you just go around and plant them like this, like a dispenser. He just took a pipe and made that. This is someone who he had his computer stolen in college 4 times. He got sick of it. He built a home security system. You get hit with 400 volts if don't steal. And my favorite, you send a text message home and your rice porridge goes on. This is one of the coolest things. But there's all this really innovative stuff, right? But look at how they're built, right? They don't look like an Apple product. They don't look like like something that you can make 100 of, 1,000 of. So we're putting together as well now a prototyping and small-scale manufacturing facility to allow people to bring their ideas to reality. And that's what we're really excited to be working on. And that was so that you can build where it's going to be used. That's really important to try and shorten that life cycle. And so to bring it a little back, one of the things about speaking to your users, right? Again, working and building right next to the people who you're going to serve. When we put the brick out there, it was really out there. At first, it was, like I said, scratching our own itch. But we were impressed and surprised, but we figured that schools and education would be a great market, but we were surprised to see how much interest there was actually. A huge portion of the folks who were interested in brick have been schools and in the education department industry, and that was really exciting for us. So we have been looking at how to better support that space, and one of the reasons why it was just people started calling, I need that. Like, hey, we have a real issue. Someone gave us a computer. It just can't really even get online. Kids, we have phones, but like the internet's always a problem. There's various different things. Or we're using this open educational resource stuff, but we're not connected. And there's always these problems. So we were out testing with a partner called Elimu here just recently, and it was quite fun and really inspiring. And what we're seeing is this huge need. And so we've been really trying to develop and design towards that use case. And what that looks like for the brick, right, is at first it was really just designed to improve connectivity, very resilient connection, right? And that's important in a school in general. As I mentioned, though, there's a hard drive on there. And there's a few other things we're building. What that means is you can put content on it. And what that means is that if you're running any sort of program or class or anything, you can have it locally cached and synced so that it feels like you're on the internet during the time of class, even if you're not, right? Everything's there locally. And then it syncs up to the web at some point between that class and the next one. So it doesn't matter if you have a full-fledged web connection at the moment of class. You're not going to be worried and trying to refresh the page all the time. And to make that even bigger and better, we've plugged it with what's called a microserver. And that's, for those techie folks out there, what's called a Raspberry Pi. And a Raspberry Pi actually just plugs right into the brick through those open ports, as I said, in the back. And that puts a really resilient connectivity device and a server all in one. The screen is exported to the computers, but that kind of creates this ability to have a local cloud, a local internet connection that can run applications, that could be running different types of applications, videos, classwork, classes run on these tools and applications. All the content could be there. If you think about that, that's like, basically that means that anyone that gets a 2G connection for 1 hour every week can have access to the entire internet, right? It only syncs 1 hour a week, but they have the feeling of everything they need right there. You could locally cache Wikipedia, you could have OER Commons on there, you can have many other things. And then that gives you access to all of this. Some folks call it like fog computing, yet a cloud comes down. But we've been doing some interesting stuff in this space, and we're pretty excited. This is actually happening right now. So we started delivering the very first set of bricks in July, we've now delivered about 1,000, the first 1,000, and getting feedback and constantly improving. It's very challenging making hardware. That's why they call it hardware. But that's most of what I wanted to tell you about today. I think the thing to really take away is I'm inspired by the fact that all the folks that I'm working with who are telling this, they're in Nairobi, right? They're working there, and I'm here to try to help do my best to tell their stories. But they're not spending their time here and flying over there once a year to do the work. It's quite the reverse. So thank you very much for having me.